Hello again, HDExaminers. This is Jeff Morrow from Sierra Analytics, welcoming you back to our YouTube channel, where today we're talking about what's new in HDExaminer version 3.1. So let's dive right in. The first feature I want to show you is that here in the uptake plot, you can now click on individual points to go to that result in the analysis view. So if I click on one of these shapes here, it will take me to that result. In some cases, the shapes will kind of badly overlap, and if you click on one, in that case, nothing will happen, but you can still zoom in so that they separate out like that, and then you can click on an individual one, and it will take you to that result. So that's the first new feature. Next up is the Volcano Plot. And if you've used the Volcano Plot before, you probably know that if you right-click in previous versions, you could copy or export the visual of the plot itself, but you couldn't previously copy or export the Volcano Plot data. Well, now you can. So if you right-click on a Volcano Plot and select Copy Peptide Plot Data to Clipboard, you can then bring it into Excel, paste it there. And what you're looking at here is a bunch of columns where the first is your protein name if you're in a project that has multiple proteins. The start and end is simply the start and end residues for each peptide. And then for each peptide, you have the two states we're looking at, in this case, mutant minus wild type. At the 30-second time point, it will show the difference for each peptide. And then the next column is the p-value of that difference. And then similarly, we have the same difference, but at the 240-second time point and the p-value and so forth. So for each of your time points, you get two columns per peptide, one for the actual measured difference and one for the p-value of that difference, which corresponds exactly to what you get if you mouse over any of these points in HDExaminer. The next new feature I'd like to show you is batch overrides of retention time from a table that you create yourself. So why did we add this? Well, so a few users of HDExaminer out there are using HDX within a larger workflow where they're doing other analysis on the peptides and in some cases are doing external retention time analysis to get a really tight and accurate retention time window for every peptide. Some are doing that, for example, in Skyline or other external tools. So what you can do now in HDExaminer is if you have these retention time windows that you want to use in HDExaminer, you can create a table of retention times, import that into HDExaminer, and it will import those as though you had done manual overrides for each of those results. So how do you do that? Well, first you have to create a table. I have one here. This is a very small one. It only has 6 results in it, but you can put as many as you like. The table should have 5 columns, no column headers. The first column is the mass spec data file name. It can be a full path if you want, or it can just be the file name. But if you do in either case, you need to include a file extension if it has one, such as .d or .raw. If you don't have that, it won't work properly. The second column is the sequence of the result you wish to override. The third column is the charge state of the result you wish to override. And then the fourth and fifth columns are the retention time range, start and end. So you create a file like this in Excel or whatever spreadsheet tool you use, and you save it. Then you go to your data file, your project file, and you select any experiment and any result. It doesn't matter which one. You just have to right-click and select retention time overrides from table. And then you import the overrides file you just made, and it starts calculating as though you had done the individual results. So what that's doing is going through your spreadsheet line by line, and for each result you gave it, it is redoing the calculation as though you had dragged a range here in the chromatogram view. So you can see they're starting to come up already. There's a couple of them there. And so that's what you can do. Now, as I said, it doesn't matter which data file you've selected or which result you've selected when you do that RT overrides from table selection, because it's going to take the mass spec files and the peptides from the file you import, not from what's selected here in HDExaminer. The last feature I want to show you today is the Woods plot. Some of you may have seen such a plot in the literature. This is sort of like a butterfly plot or a residual plot, but instead of the x-axis being peptide number, the x-axis in this case is actually the residue of your protein. So instead of each peptide measurement being an individual dot, it's actually a bar showing the length of each peptide. So what you're looking at here is we've selected mutant versus wild type, so it's the difference in the mutant and wild type for each peptide. And if we zoom in, we can see individual peptides and individual time points as well. So here is 323 to 333 at 14.4 seconds. And if we click on that, it will take us to that uptake plot. The various color codings represent the time points, and the key is up here at the top. And the bars, as I said, are the peptides. So the Woods plot is best suited for relatively small projects with not a huge number of peptides, because as you can see, the more peptides you have, the more crowded this gets. So if you have a very large project with tons and tons of peptides, well, the Woods plot may not be the right tool for you. But if you're running a smaller project, then the Woods plot can be a really good way to see differences between your two protein states, or to see the behavior of your protein in a more spatial way that isn't just the x-axis being peptide number. So to recap the new features, first of all, you can click on a point in the uptake plot to view that result in the analysis view. You can export the Volcano Plot data in addition to just exporting the Volcano Plot image. You can override retention times from a spreadsheet file that you provide yourself. And finally, you can look at a Woods plot for your data. There's also various bug fixes and performance improvements, especially there are performance improvements related to water's ion mobility data. If you're interested in trying HDExaminer 3.1, please let us know at automation.hdx at trajanscimed.com. If you are already an HDExaminer 3 user who is under a support contract, you can upgrade to this version for free. Just contact us and we'll get you set up. If you're not under a support contract, or if you're using an older version of HDExaminer than 3.0, then contact us about your upgrade options. Once again, this is Jeff Morrow from Sierra Analytics saying thank you for watching.